All right, so finally, let's just look at some hands-on. I think there's something that I left up here. Particular place where we did a break. Okay, break. All right, right here. This is also meant to be. We called it an hands-on, but I think I accidentally put it up there early. Cut this again. Paste in here. Cut this. Paste in here. Then Control A and Control X. Alright, so I can close this and delete this entire break. Okay, so we can say, what will this be? Alright, so getting started with data frames. Alright, so let's just change this to getting started with data frames. Getting started with data frame. Alright, so that's nice. Now we can go all the way down. Okay, so I can just drop that up here. Okay, as a comment. So just create a data set right here. Okay. Paste. Boom. Just call this df or pd or retail. So system ID, I'm passing a list of random of sequence numbers. So 101 to 101, 101. Okay, let's pass in the list ourselves. 101, 101, 102, 102, 103, 103, 103 as well. So I just have 3 103s. So that makes it 7. Don't want to say month. You can just split that up. January, February, January, Feb, Jan, Feb, and March. Okay. And finally, you can say sales. Let's give some higher value than before. 3050, 3560, 2900. I'm passing empty value, none. 4200, 3980. How many do we have? 1 2 3, 1 2 3. Okay, we want one more, so that can be, let's just say 4100. Okay, so put a comma. Okay, I think we're good. So far, let's add one more data. Let's add transactions. or 120, 130, 110, 98, 150, there's 160, 155, 158. Okay, so this is what we have, just a generic data set, and then we'll print the data frame out. Let's see what it looks like. We'll say retail. All right. Oh, okay. I omitted the splits on this, so do dot split. Then I'll put a comma. I'll run that again. Okay. So we now have it correctly. Now you can see we passed in none, and of course it is not a number. That's still the way it will appear. So let's add a code up here. So let's check our data. Retail.info. So we can see store ID is integer. We should have made that text. Dot split. Right, run that again. Okay, an accidental. I forgot a comma. Forgot a comma. At what point did I forget a comma? Before 101. Okay, I forgot a full stop, not a comma. Before split. Okay, good. So if we check this again now, this should be text. All right, object, float, and integer. So the sales alone should be a text. So let's say describe. Let's say inspect. We're not cleaning yet. See inspect. All right. So just add few columns. So say retail.describe. Describe. This is what we have. Sales and transaction. Now we can pass in a variable, an argument. I mean, I'll say all. So you can see it's going to do for all. We want to get details about all the data. Of course, where is not a number, we just get, because I cannot take average of non-numbers, non-numerical columns. And that's why most times by default, it only picks numerical columns. Okay. So that's all we have. Is there any other thing to check? I think we're good. We've seen a majority of what we need to see. So let's clean. So let's undo the missing value first. Based on what we did before, we can say the retail, then sales, the sales, right? Sales, yeah. So that's where we have a missing value. And then we'll say df retail. I'm so used to data frame. So we'll say retail.sales. Then we'll say fill any. In this case, we want to fill it with the average value of the sales. Oh, I keep typing df retail.sales. And now say dot mean, right? So we did that earlier when we are looking at handling missing data. So this should not be strange anymore. If it's still strange, it's good you take this back and run it again. Okay, so we can just run that. That's the only thing we have. So if we print df retail again, we should not have any non-value. You can see everything is now clean. So what else can we do? Now we've done handling missing values. So we can do feature engineering. Feature engineering, which is basically getting new columns from existing ones. So we can say, for example, retail, no retails dot average. What is our data about again? Okay, we can let's just say something. Let's say average ticket, and that can be. So I want to create a new column. Average ticket does not exist before. Say retail sales single, then divided by retail, no, not relationship, retail transactions. Okay, so this will create a new column for us, and then we can print our data here. Retail.add. We don't want to see everything for now. We just want to see the first 5 rows. Okay, so you can see we now have this in there, first 5 records. Okay, so we can okay, I already have them listed here. Okay, I want to select some columns. So let's say we want to select some columns. We can just do df retail, my bad, retail, then store id, comma. So that should be a list of lists. So passing another list, square brackets and square brackets. This should be opening only. Okay, so I want to select just a few. I want to select the month, and I want to select the sales. So I can do .add again, but this time I just want the top 3. Okay, so you can see we can select certain columns and check what we have in there like that as we please. Okay, so let's filter greater than a certain amount. So we can say, okay, since we're using greater, so we can say I sales, then we'll say retail. As usual, we open a square bracket, then we pass in our condition inside the square bracket. So retail into brackets, sales. So we'll say where sales is greater than, let's say 3,500. Then we want to see I sales. Okay, so this is what we have. We have 1, we have 3, we have 4, we have 5, we have 6. Okay. Now is grouping and aggregation. Okay. So we want to group and aggregate. So we can say, for example, monthly summary, because we have different months. So we can say monthly summary is equals to, so come back here. So we can just open a parenthesis and then declare everything we want to do. So say retail dot, no, just good way to organize our code, group by. So let's say, let's go back to our data. You can always reprint it down here. Retail. Okay, so the ID is duplicated, the month is also duplicated, right? So we can group by the sales and the month, or the store ID and the month. Store ID and the month. So we can then say, then group by should be like this. Then dots aggregation, we want to aggregate. So for the aggregation, we can say total sales equals a tuple. That will be sales sum. Then we want to do transaction total, or total transaction. Total, how do we shorten transaction? Transactions. Okay, let's just do it that way. Total transactions. And in this case, we want to pass in a tuple as well. Transactions. It's not coming up. Okay, I was waiting for that. And since it's numeric, we'll do a sum. And finally, average ticket. Then we'll say are you jumping avg underscore ticket mean. Okay, mean, which is average. Okay, and finally we want to reset index, so we don't have that funny float that we used to get. Remember that? Okay, so this is nicely done. I just show monthly sales down here, a monthly summary. All right, we're getting an error. Says tuple has no object reset index. Okay, I passed that into the aggregate function, and it's not supposed to be. So that is supposed to be outside, on the same level as these guys, right? But outside the bracket. Okay. Or to make this more clear, I'll bring this up. No, I think it's perfect like that. But I'll just close the bracket at this point. Okay. All right. So we open it here. We have all the lists, and then we're doing reset index at this point. Okay. What else are we missing again? So it says transaction does not exist as part of the column. Transactions, okay, that's in plural. I'll add s. I'll run it again. Fine. And now we get a total. We're grouping on two columns, so we can see what we have. Total number of transactions, the average ticket, and yes, we've just created a monthly sales summary. Just created a monthly sales summary for our data. Right. Right. So far, I hope you're enjoying the hands-on. Right. Is there any other thing? Don't need this, so take it out and take it out. Okay, so we've completed the first one. If we go back up, I believe those are the objectives we have. Okay, not here. We have been able to do one or two things with these. You can feel free to expand on this. Now let's look at hands-on 2. Now we have a scenario in this case, and the scenario says a hospital needs to merge patient demographic with lab results and generate a report ready data. Objective was to clean messy string date columns, merge the data sets, create new features, that means feature engineering, and then we export as CSV. We want a downloadable file, right? So that means the first thing we must do is let me take this out. we have to create a data set. Okay, that's why I left it up there. Where is it again? We have to create a data set, and intentionally we have to put in messy, maybe date string in there, right? So we want patient first, since we are merging the patient demographic with the lab results. So we want patients, then we'll say pd.dataframe. Then we'll open this. Let's start with patient ID. Since this is the patient table, we can just do ID instead. So we'll do ID, then we'll pass in, what's it called? Let's just give them some random numbers. We don't want to really do much. So we can pass in a list, range, then we should just pass in 1 to 5. Okay. So the next thing we want to have is name. And want to have it as, let's do intentionally passing John Doe. Should also have spaces. Really want to mess things up. Well, we don't want to mess things up, but we really want to simulate when things are messed up. So since we want to simulate the space and all of that, we don't want to do split in this case. So we'll just do it ourselves. And then we can say Jane Smith. Can say Mike Johnson, John, okay, Mike Johnson, then we can say Macar, okay, let's just put in a good name, Bob Gaz. All right, so this is the names of the patients, or these are the names of the patients. In this case, I want us to do something more fun. Let's say McLaurin. Then we use hyphen so that we can also take it out, because we are not supposed to have hyphen in there. Okay, so put it in square brackets because we're not splitting. So you can see how messy this is. Then the next thing is we want to put in, let's say, DOB. Of course, details like this will not be public. Okay, so what can we split on? I think we can split on comma. So I'll do a split on this 1985 05, then 10. Then we'll put a comma, say 1990. This time we're using slash, which is genuinely possible, right? 15, and we can say 1978. This time we're using hyphen again, 01 20. And finally we can use 1995 12 01. Okay, so split on comma. So split on the comma, and then say height. height in centimeter, right? So we know the unit. So we can just say 175 non 180, then 165. All right. So this is what we have for the patients. Now we have the patient settled. I think they're just four. All right. So 1 2 for lab. So say labs or lab results. Let's just keep it lab shorter. pd.data frame. Okay. Then we'll open it up. Then we'll say patient ID. Patient underscore ID. 1 2 3 4. So we can just copy this again. Patient ID. Then we can say, let's say cholesterol level. Cholesterol. Or 180, 190, 210, 170. Okay. HDL. Can put in 50, 55, 45, and what else? 60. And let's put LDL as well. 110, 120, 140. Let's do 95 now. Okay. Let's take this out. So this is what we have now. We have both patient and lab data. So let's run our data code and print both of them. We'll print them separately. Okay. And then we'll print code. Patient first. Patients. And then we'll print the labs as well. Labs. Okay. So run that. So we can see. You can see the spaces and the rest. And then we can do this. And then you can see the labs. By the way, HDL is high density lipoprotein and LDL is low density lipoprotein. And they're just they're both types of cholesterol in the blood, but they do opposite things. Okay. So the high density, good cholesterol, low density, bad cholesterol. All right. Now that we have our data sets, we want to clean, right? We want to clean them up because we really have them messy, especially the patient table. They are really messy. Okay. So how do we do that? We just call, for example, this column first, the name column. So we'll target the name column first. So we'll say patients, square bracket. Then we'll put in the name. Then we'll say it will be equals to patients dot name again. Now remember to access this, because the type of patient name will be an object, so we have to use the string method to get it out, right? So we'll do .str, then we'll now pass in the method. So we want to strip it first, right? We want to remove the spaces. Remember, we added extra spaces at the top, at the beginning. We want to remove the spaces. What else do we want to do? We want to give it a proper casing. So we can use the title case, first letter of every word. And for McLaurin, we want to remove the hyphen and pass in nothing. We want to take out the hyphen. So say dot str again. Then we'll say dot title. Then finally dot replace. Then we'll look for hyphen and replace it with nothing. Okay, so that's for the name. We have for the dates, and we have not probably worked with dates before, so we want to do for the dates. So we can say patients dot dob. So let's look at what we have in the date. So we're seeing different formats. We just want to what convert it to an actual date or a proper date. So say patient again, then we'll pass in dob. Now we have to say pd to date time, right? Remember when we did pd to numeric, so the same way we'll do pd to date time. So come here, okay, pd dot to, that's called date time. So we're passing this in, and we want to say if there is any error, remember we want to do what? Coerce it. Errors, then we'll say coerce. Right, just like that. Then we'll close the bracket. So that will be for the date. For the height, let's see. Okay, we have a missing value, and I will fill the missing value with let's say the average height of others. Okay, fill it with the average height of the rest of the patients. So say patient dot height. Why is it not coming up? Yeah, we have height there. Okay, I'll just type it in. Patient dot height underscore centimeter is equals to patient height in centimeter. I'll do dot fill NA. I'll say patient height dot mean. Okay, so I want to fill it with the average of others. Is there any other thing we want to do? Nothing else. That's basically the cleaning part that we want to do. Okay, so we'll run this and then we'll print patient at the bottom again. Okay, so if we look at this now, so everything is now looking proper. I think okay, I omitted str right here because the hyphen is supposed to go, but I omitted str. So str again, don't replace. So let's do that. Okay, good. So we have it this way, and our data is now clean. We can now proceed with what we want to do. And by the way, intuitively, even if you have not seen this before, we are seeing NAT, and earlier we have seen NAN, not a number. So what do you think this will be? Since this is the days column, so it will mean not a time. Okay, not a time. Why? Because it's not doesn't understand the slash. Okay, doesn't understand the slash. So one thing we could have done first is maybe replace then so that we can get it correctly. But just so you see that we have not a time, that's why that is used there. So let's merge the two tables together. Let's say df, and then we're going to call it patients.merge. We can pass in lab, and then we'll say on this will be on patient ID, patient underscore ID, and want it to be a left join, so we'll say how, and we'll say left. Okay, I think I should cut this up. To end, then print df right here. Okay, so we're getting a key error. Okay, if you remember, we used ID for patients, so say left or left on ID, right on. Okay, so right on patient's ID. So run that again, and now everything is now printed properly. So you can see we've been able to merge the two tables together. So you can see the full details of the patient and their lab results in one go. Okay, so let's create more like a risk flag, right? We'll say high or normal or low, something like that. Okay, so just bring this into this place. Just take this out, and I normal etc. So for us to create that, we'll do our df, the merge table now, then cholesterol underscore risk. That means we're creating a new column, right? Feature engineering. Then we'll say mp dot where. So mp dot where. Remember, this is one of the ways we can maybe fill missing values or find something or replace something, right? To replace values. So we'll say df dot cholesterol. Now, if the value is greater or equal to 200, that should go away. Okay, then it should be high, else it should be low. Okay, so we're saying look for this. If the value is greater than 200, it should be high, else it should be low. So let's print df again and see what that looks like. Okay, so just like that, we can see we have high. So this is the only high we have in there. So others are low. Normal, I think we should put it as normal, not low. Normal. Okay, so we have it as normal and high. Okay, let's continue. What else do we have? Okay, we want to create age group. Now, for us to create the age group, we need to create an age column first, right? So for the age column, let's just say today, pd dot timestamp. Then we can pass in date. I'm passing any date in there. Let's say 2026. Let's say 005 and 04. Just passing that date. And then we'll say patients. Patients column age will now be today minus patient DOB. Patient DOB. Okay. What is off? Okay. I have two single quotes. Then we can do date time, right? We have DT. Then we'll do days. So we can do a floor division by 365. And then we'll print patients. Okay. Let's see what this gives us. All right. Just like that. I've been able to get the column age for the patients. Okay. So that means we have to probably run this again. Okay, age is now included. Let's run this again as well. All right, age is now included. So right here, we can now create the age group. Okay, so age group. I'll rename this to age. So here we now have age group. Then we can say df dot age group, which is the column that does not exist before, right? So we can say we have a method called pd dot cut. I'll pass in div data frame age, pass in the bins, just the way we do for histogram. So we'll say 0, 29, 49, 120. Let's just jump like that. Then we'll say labels. Labels. Now for the labels, we need to pass it as a list. So pass in a list. Then the first one can be less than 30, of course. The next person or the next group will be 30 to 49. Then we can say 50 plus, right? 50 plus. Okay, this should do. Then we'll print our data frame again. That should not throw an error. All right. So of course this person doesn't have any age. So we can see the age range for individual person. So this is 41. This is okay. Let's do it in such a way that we cover this. No, it doesn't matter. Let's just leave it that way. Now finally, let's click on interactive sheets. No thanks. I wanted us to see that, but you can feel free to explore that on your own. Now finally, we need to export our data. So this new data can be exported as a result. Okay, how do we do that? We'll say df, then we use the method to CSV. You can see we have to CSV to clipboard to HTML to Excel. See all of them. So just use to CSV this time, and then we'll call it let's say hospital cleaned dot CSV. Then we'll say index, say false, right? We don't want all of these 0, 0, these parts to be included. So it says index is false. You can then print maybe save to hospital, whatever it is. So I think we're good. Good. Yes, we are. We are. Okay. So this will download the saved file. Now we have to look for it under our file, and then under the files there, we should be able to find that particular file. Okay. So let's run it. Or there's another way by which we can download it to our what's it called, our machine directly. Okay. Well, let's just run it first. Then run it. Then it's done. Let's check here. You can see like that. I can download it completely, and it should download. You can see it's downloaded like just like a CSV file. So we can open it up. I would say, do you want to convert? Don't convert. All right. So this is what we have. So you can see exactly the data we worked with. You can see everything like that has been downloaded, and we can view it in Excel. So yes, we have now seen an hands-on exercise or hands-on exercises on how to use data frame for cleaning, for manipulation, for analysis, right? We've done pivot table, group by, summary, and all, right? So just a little exercise for you to strengthen your hand more on what you've learned. We'll take the exercise we just finished a little bit further for you, okay? So back to our Google Colab, I'll just close this. Let's look at what we have for you. So hands-on for you. Now you can calculate the BMI, right, using weights. So just create some dummy weights, some fake weights. Okay, so create weights, add it to the data set, then create the ratio, LDL HDL ratio, and flag anything as 3.5, greater than 3.5 as risk. Then split the name into first name and last name. Okay, if you want more, you want to go further, you can create a reusable function that can clean the name, right? You can take a column, clean all the names, standardize casing, spaces, removing all of those things. You can do much more with that, and it is a good thing that you give it a good shot. Okay, so when you're done, copy the link to your notebook. Just click on this button here that says share, copy the link to your notebook and share in the. So when you're done, copy the link to your notebook. If you click on share notebook, it's going to pop up. Then you set it to anyone with the link. You copy that link and paste in the Telegram channel below. Link to join is in the description below. And yeah, for this and more on Python, I will see you in the next video.